Hey everyone, welcome back to my channel. Today I'm going to start with the statistics series. So, it is a prerequisite series that is needed before we begin with the machine learning. So, what if I tell you that good decisions are based on the facts? Facts are based on the data, and to understand the data or make a sense of it, then we need to learn the statistics. We should know about the statistics. So, as per the definition, you can see statistics is the science of collecting, understanding, and learning from data. So, let's break it down. Collecting the data means you gather the information through different surveys, experiments, and observation. Then, understanding means after gathering the information, you will visualize that data in form of different charts. Okay, for example, you plot that data in form of bar chart, so you can able to get the insights what your data is trying to tell you, so you can get a more info from the data, and you can use that data to fit to the machine learning model that is using the statistics under the hood, and it can predict the future outcomes, or you can make a smart decision based on that. Now, why you should care about the statistics? So for the first point is, it is the foundation of machine learning and AI. It helps you to discover the hidden patterns. Means when you get the data, it is a raw number, you don't know that what is inside the data and what story is trying to tell you. Okay, so when you plot it, you can get insights from the data, you can understand the story from the data. So that's why it's helped you to discover the hidden patterns. Then you can make a smart predictions. As I tell you earlier, you can feed the data to train the machine learning model, which uses the statistics under the hood, and it will make the smart predictions. And statistics is used in all the machine learning algorithm that is used to build the AI systems. Apart from that, it is used in the variety of sectors, that is from healthcare to finance. And generally, I can say that it powers the solution that changed the world. Now, let us go through an example. So, this is the study hour data. So, the question arises like how many hours one should study to get a good grade. Okay, so this is the raw data. So you can see that the first student, Alice, she studied for 2 hours and scored 45 marks, and the last student, Eva, she studies for the 9 hours and scored 92 marks. Okay, so currently this is just a raw data, it is a numbers. Okay, now we need to understand the hidden pattern. So let's see. So when I plot this data in the form of bar chart, so you can get a insight here, clear insight. So you can see that the student who studied for 2 hours like score 45 marks, and the student who studied for 9 hours score 92 marks. So more you study, more you will score. So this is the pattern, and it is clear now. So with the help of visualization, you can make the complex data simple to understand. So as I told you that it helps you to identify the hidden pattern. So for example, you feed the data to the machine learning model. What it will do, it will find a linear relationship in the data. So from that linear relationship, it will derive the formula. You can see here, for example, the machine learning model derived the formula this to figure out the score. And the formula that machine learning model derives, it will be like 95% of the time it will predict the true value if the machine learning model is trained properly. Now for example, a question arises, a new student comes and he tells that he studied for 7 hours, and we need to find the future score of that student, okay, using the formula that we derived from the machine learning model. So when we feed the score into this formula, we get the 80 points. Okay, so this is like, as I told you, that machine learning model will be, if you have trained it on the proper data and you have done the proper evaluation of that model, I can say that 80 to 90% time it will predict a true value, correct value. So machine learning model is used, sorry, statistics is used in the healthcare domain. So based on the patient's past data, okay, you can predict the disease. It is also used in the self-driving car. So there are a lot of sensors are in the self-driving cars, and based on the data from the sensors, okay, you can predict, you can avoid the accident. It will help you to understand the traffic pattern. It is also used in the recommendation system. So for example, Netflix recommend you the new movie. So how it recommends it, based on your search, based on the movie you watch, okay, so it uses the statistics under the hood, and based on it, it will recommend you the best movie that suits you, okay. It is also used in the financial domain. For example, we suppose based on the historical stock prices, we want to predict the future stock price, okay. So it can help in that case also. So there are two type of statistical tools, that is descriptive statistics and inferential statistics. So descriptive statistics will help you to describe and summarize your data, okay. It will help you to identify the essential element in your data set, whereas the inferential statistics will help you to make predictions about the larger population from the sample data, that is a random sample data. So as I tell you about the descriptive statistics, it helps you to summarize and describe your data. So the essential elements in the data set, for example, are average. So for the study or column, we find the average hours. Okay. So average hours comes like 5.6 hours. So you can conclude that average study hours is 5.6. Then suppose you find the center point, okay, center value in the study hour column. So suppose it comes as a 6 hours. So you can also conclude that half of the students studied more than 6 hours. And spread or variance, okay, so it gives the range in which your score lies. For example, scores range from 45 to 92. And now coming to the topic, that is inferential statistics. So as I tell you that it helps you to predict about the larger population from the sample data. So why I have used this term? Because for example, there are, for example, a city has 500k people, okay, and you need to find the average age of those people, but you cannot go to each people and collect their age. It will be a very time consuming thing. It will take a lot of effort. Okay, so instead of that, what you will do, you will choose, okay, the 1,000 random people, and make sure that the data is not biased, means it does not falls into the particular category, okay, like for example above 40, below 30. So you will make sure that it will vary. Then what you will do is you will find the, for example, the average age you find from the random data is 34, okay, and so based on that you can predict the age of the uh, population of the city. Then for example, the data that you gathered, okay, the of the 1,000 people, so for example you figure out that around 600 people lies below 40 years, okay, so you can make a conclusion based on that, that 60% of people in the city has the age that is below 40 years. And it is also used to evaluate that the prediction, okay, that you predict is how much percentage correct, okay. So for example, you can measure the confidence. So suppose the average age was 34, means it can vary. So I can predict that 95% I am confident that the average age lies between 30 to 36 years. Yeah, that's it.